Hi. Last class we have studied about properties of addition of whole numbers and properties of subtraction of whole numbers, isn't it? And we have done checkpoint questions also from it till 17 question. Question number 17 we have answered in the last class, isn't it? Today we are moving to the properties of multiplication of whole numbers. In case of addition and in case of multiplication, all the property holds. In case of whole numbers. What are whole numbers? The numbers 0, 1, 2, 3, 4, 5, 6, etc. are called whole numbers. And the least one is 0, isn't it? And 0 is called the least number. And also in last class we have studied it is the additive identity. And today we are going to study about properties of multiplication first. And the first one is same property, closure property. What is closure property? If A and B are whole numbers, their product is also a whole number. For example, 3 into 5. 3 and 5 are whole numbers. Their product equal to 15 is also a whole number. Isn't it? Next we are moving to commutative property. What is commutative property? There are two numbers. Okay, commutative property includes only two numbers. If A and B are whole numbers, then A into B is always equal to the right side. That is B into A. If you interchange the numbers, then also the product remains the same and also it is a whole number. For example, 3 into 5, 15 we already studied. Reverse order you multiply. 5 into 3 also giving 15 to you. So, multiplication of whole numbers is, what is it? Commutative. Isn't it? Next one, associative property. Same as commutative. Here we need to consider 3 numbers at a time. 3 whole numbers at a time. If A, B, C are whole numbers, the product, any order you can rearrange them. Okay, but the last product will be the same. That is, first teacher has taken A outside, B into C inside. The right side teacher has taken A into B inside, C outside. But they are the same. Okay, let us move to the fourth property. Before moving to the fourth property, multiplicative identity, let us go through one example for the same associative property. Teacher has taken 3 numbers. This is actually 18th question. Checkpoint question 18A question actually. So when you are answering checkpoint, go through the same. 20, 28, 5. In that they told you multiply the numbers using suitable arrangement. So any one of the method enough for you for doing checkpoint. This is associative property. That's why teacher is doing the product 2 times. Okay. So 20 is first A teacher has taken. Remaining 2 teacher has grouped. So right side what you have to do? First 20 has no change, you write down. Into what is the product of 25 into 5? 25 into 5 is giving 140 to us. So which is equal to 2800. Okay. Similarly other way you find out. First you multiply first 2 numbers. Then multiply the third number. First 2 product will give you 560. 560 into 5 is giving same product 2800. That means whole numbers are associative in case of multiplication, or multiplication of whole numbers is associative. Okay, let us move to the other condition, that is fourth property, multiplicative identity. In case of additive identity, we studied that if A is a whole number, A plus 0 is giving A itself. But in case of multiplication, A into what number is giving A? 1. That is, A into 1 equal to A, or 1 into A is also A. And 1 is called multiplicative identity. 0 is additive identity. 1 is multiplicative identity. Let us move to properties of division of whole numbers. Division and subtraction are little bit same. Only change in the operation that we are doing. But the properties and all, it holds in the same manner. Because when closure property, when you consider, you can see that the division of 2 whole numbers is not always a whole number. Subtraction case also we studied, isn't it? subtraction of two whole numbers is not always a whole number. Sometimes it's a whole number, but it must be true for all the whole numbers. Then only we can say that the property is true. Okay, but here it is not possible. For example, we can consider one example and we can move to the. Let us see the example. Which one? Teacher hasn't written now. That's why I told you. Sorry. There is a small mistake in the page. Sorry for the inconvenience. Let us continue. So, closure property says that A by B not always a whole number. For example, teacher has taken two whole numbers 3 and 6. So, you divide 3 divided by 6. We can divide both numbers by 3. So, 3 by 3 one time. 6 by 3 2 times. So, answer is 1 by 2. 1 by 2 is a fraction. It is not a whole number. Isn't it? So, we can write it is not a whole number. So, division is not closed. Okay. Let us continue with another case. That is commutative property. Commutative property says that if A divided by B is not a whole number, what about B divided by A? That is also not equal with A divided by B, isn't it? So, in case of division, the commutative property does not hold, isn't it? Or division of whole numbers is not commutative. For example, let us see. Same repetition. 3 divided by 6, 1 by 2, not a whole number, you leave it. But when you do 6 by 3, value is 2. Are they equal? No. So, you leave it. Okay, you needn't want to go through the example. You just get the idea only. Okay. Let us continue with some other cases. That is associative property. What is associative property? Says that if for 2 numbers the property does not hold, what about for 3 numbers? Never. Okay. So, needn't bother about this example. Teacher hasn't completed it because you haven't studied about reciprocal and their multiplication, etc. Isn't it? That's why teacher did only half of the questions on both sides. Okay. That you will study in higher classes. Okay. Now, what we have to write is division is not associative. Let us see why. If you take the 3 numbers as 3, 6 and 9, we can see that 3 divided by 6 is 3 divided by 6 divided by 9. When you write 3 divided by 6 by 9 is only 2 by 3. So, 3 divided by 2 by 3 may not be a whole number. Similarly, on the right side, 3 by 6 we have 1 by 2. 1 by 2 by 9 is also not a whole number. Let us continue again. That is property of 0. There also we have said in case of subtraction, 0 is subtracted from any number, we will get that number itself. That is A minus 0 is A itself. Similarly, here also property of 0. What does it say? 0 divided by any number is always 0. For example, 0 by 5 is 0 itself. But the reverse process is not defined yet. That is 5 divided by 0 is undefined or it is meaningless. Isn't it? So, only remind in your mind 0 by any number